Hello all. Today we are solving LeetCode problem number 799 Champagne Tower. So we are given a pyramid, glass pyramid basically. So where first row has one glass and second row has two glass, in fact, until 100th row. So the row starts from 1 till 100. So each glass holds 1 cup of champagne. So you can say that each glass maximum capacity is equal to 1, and you have 100th row, so it looks like something like this. The first row has 1, second row has 2, and third row has 3. So basically I have written down the buckets, a kind of thing here. This is the champagne, this is looking like buckets anyway. So then some champagne is poured into the first glass at the top. So we start to pour at the top, and when the glass is full, any excess liquid is poured fall equally to the glass immediately left and right. So when this is filled completely, that is the capacity of 1 is the maximum capacity. So when it exceeds the maximum capacity 1, the remaining champagne gets splits equally into and poured into left and right equally. So this is the condition given here. So now what we have to find here is, after pouring some non-negative integer cups of champagne, return how full the jar, that is jth glass, in the ith row. So that is what exactly we have to return. So what is the amount of champagne present in the jth glass in the ith row? So we have row 1, row 2, and row 3. So in the glass can be second glass, which is jth classes can be second class, and row can be third row. So in that case you have to find the second class, which is nothing but this, and we have to return the amount of champagne present within this class as the output. So that is what they have given here. The parameter are the poured value, the total amount of champagne which is being poured, and you have the query row and query class, so using which you will return the value or amount of champagne present within the class. So how do we solve this problem? So basically what I am thinking here is to go by the simulation part. So to better understand this, we have to build this complete tower, right? So this tower can be represented in matrix format. So that is what I have written here. So we will consider the mainly the 3 rows. This will be indexed by 0 to 2, but this, for better understanding, I will have it as 1, 2, and 3. So yeah, so this is how we will be having the rows. So while representing this, again also, uh, okay, it's, let us understand with 0, because if I'm overwriting this will be looking clumsier and will be very hard to understand, in fact. So the first one will be 0 0. So first row has only one glass, and second one has 1 0 and 1 1, which is 2 glass here, and the third row has 3 glass, 2 0 2 1 2 2, and it goes so on and so forth. So this is how it goes. So first thing is you have to build all these one, and you have poured value equal to 4. For example, we can consider this example poured value as 4. So which means when you start pouring here, the capacity is 1 full, right? One will be filled, and the remaining will be 3. So now these 3 will be divided equally, and this will move to right, and this will move to left, and this is left, and this is right. So in this way it gets equally splitted and it gets filled, right? So which means you can say that this will be 1.5, and 1.5 will move to left and move to right, right? So which means now while filling this one will be completely filled, and this one will be completely filled. So what will be the remaining portions? It is 0.5 and 0.5. So this 0.5 will be moved, this split it into two half, and it will be moved left and right. So from this champagne glass, the left portion here, it will be the half of this 2.0.5 will be to 0.25. So 0.25 moves here and 0.25 moves here, right? So in this way, this remaining portion is done. Now the remaining portion is 0. So similarly in right side also, this get evenly splitted, and the portion, first half portion moves left and second half portion moves right. So 0.25 moves here and 0.25 moves here. So this will be 0.25 added with 0.25. This results in 0.5. So in this way, if you see, you will have 1 and 1, 1, 0.25, 0.5, 0.25. So this is how you will fill this value, right? So first thing is you have to construct, next thing is you have to fill, and last thing is you have to query. So by query, what I meant is, you have the jth class and ith row, using which from this constructed matrix you can fetch the value and return it. For example, the glass can be the 2 of 2, or the glass can be 1, and you will have the row will be row can be 2, right? So in that case, this will be the answer which you will fetch and you will return. So this is how the simulation works. So this is how we are going to solve this problem as well. So with this idea, let us go ahead and code this up. First thing is, in order to create the simulation, we need the matrix to traverse, right? So levels will be equal to, everything will be initialized with 0, and this will be till I plus 1 times for I in range of query row. And since the query row, this for loop is non-inclusive, we will be adding with 1. So this is how we create the levels matrix and initialize the level, the first element to be poured. So levels of 0 and 0 will be equal to poured. And now we iterate for I in range of query row times, and for j in range, this should be I plus 1. So this is how we range, because we start with a single element each, and next 2, that is single element, and then 2, then followed by 3. So it goes on like that, right? So it's because of that it is I plus 1. So now the task is next. So how do we find next? We will use the levels of I and j, right, subtracted by 1. So at this value, whatever value is there, we subtract that by 1, and then we divide by 2. So we get the next value, and we increment the next value in the following next rows and column values, in fact, right? So if next is greater than 0, then what you do is levels of I plus 1 and j will be incremented by next, followed by levels of I plus 1 and j plus 1 will also be incremented by next, right? Then that is it. We can go and return, or in, yes, return levels of the query row and query class as the range, query row and query class. But one thing to note here is we are creating the levels only till the query row as range, right? We are not creating the complete 100th row. So in order to save the memory space, so it's because of that there may be some cases where we will have for example the port value given here is 4, right? So it may be higher than 4, and due to which in the next row, which is this is 1 2 3, so in the fourth row there may be some because of the overflow value in 3, there may be some values left over in 4 as well, right? So in order to track that, we will have min of 1 and this value, because if we do this, I think it's better to run and show this, because if you're going straight away and returning this will have the value more than 1, because we are limiting the levels to be only till the query row, not exactly the 100th row, right? So it's because of that this will give that issue, and you will not have, sorry, you will not pass every test cases. So better return levels of sorry query row and query class. So if we run this, we will be getting some test case failures, definitely. Yeah, so here you can see that it is the output is 130. Oh, this is a very big huge number. In fact, this should be expected by 1.0, right? So that is what they have asked the query row and query class. So it's because of that you have to follow this minimum value, because you cannot calculate all the overflow value into the class, because the maximum capacity of the class is always 1. So now it is working. Let us submit this, and there you go. Thank you.